Chapter 5, we'll be looking at ocean and fisheries. So quickly, let's look at our syllabus content for this class, ocean and fisheries. First, we'll look at how to outline the resource potential of the ocean, outline the distribution of the major ocean current, explain the distribution of major marine fish population. We are also going to describe the El Niño Southern Oscillation phenomena and its effect on fisheries along the Pacific coast of South America. Now, so we're going to cover quickly, we're going to cover all this content here. And this is all what you need to know relating to this topic called ocean and fisheries. So you can actually pause the video, read all your syllabus content and get familiar with it. Now, 5.1, where we look at ocean as a resource. Now, these are the major resources you get from the ocean. First, food, such as fish. This includes true fish, finfish, shellfish, and other sea animals that can be eaten. So another ocean resources is chemical and building material. So substance such as salt, oil, and sand. You can get it from the ocean. So you can also get wave and tidal energy. If you need to know how these two forms of energy is created, you can watch our chapter 2 video on energy and environment. And tourism. So seasides are a major tourist attraction where people of MEDCs, that's more economically developed countries, sorry, this should be in capital letters, are attracted to marine sites of great natural beauty, especially coral reefs. Other activities include sunbathing, fishing, diving, etc. So it's an important site for tourist destination. So transport. Ships are important to transport people and goods. However, shipping is less common to transport people now due to the advent of aviation. Now, it has the potential for safe drinking water through desalination process. So, ocean, when purified, can be purified through reverse osmosis and distillation. If you need to know more about that, to remove the salt content and make it suitable for drinking, so you can still watch our chapter 4 video on water supply for more clarity in that aspect. Now, next we'll look at world fisheries, the position of major cold and warm ocean currents. That's it. Now, what you need to know is that cold currents come from the poles, while warm current come from the tropics or either side of the equator. Now, this line here is the equatorial line, which is at 0 degrees. Now, 23 and a half degrees north and south of the equator form the main tropics. 23 and a half degrees south and 23 and a half degrees north. That's this line here. This line, this point. So from this point to this point forms the tropics. So this area, you have major warm current. So you see, the warm current comes from the tropic or either side of the poles. So now from the either side of the equator. So from the equator, you find out that the warm current move towards the poles. All warm currents move towards the poles. You can see them. The equatorial current will move and move down. This move down. So all warm currents are always moving towards the poles. Warm current move towards the poles. Now, the only thing they need you to know is to know their position, not even their name, based on your syllabus. If you read through it, you will understand what we're saying. Equatorial current still here. So they move towards the poles, they move downward or upward, north and south of the equator. While cold current move towards the equator. Look at California current coming down to the equator, Peru current moving towards the equator, the Benguela current is moving towards the equator, the West Australian current is moving towards the equator. So all these major cold currents from the poles move towards the equator, and warm current from the equator or trophic tropics move towards the poles. You just need to know that. So in the exam, if it will be given to you, to be given to you with arrows, so, and the direction of movement. So based on that, you should be able to tell which is a cold and which is a warm current. Now, the distribution of major fish or marine fish population. How is fish distributed? Now, first, you need to look at, they expect us to know how fish is distributed along the shallow water of the continental shelf. Now, a continental shelf is a portion of a continent that is submerged under an area of relatively shallow water known as the sea shelf. Now, if this is the sea, look at the profile, sea profile. If this is the sea, now this shallow part here forms the continental shelf. Why? From the continental shelf, you have the continental slope, continental rise before the ocean floor. Now, along this continental shelf, you have high amount of fish population. Reasons being that, one, this part have high amount of oxygen concentration, therefore the rate of respiration will be high there. It has high light penetration, so all the phytoplankton that are produced within the ocean, we have high amount of light for photosynthesis. Abundance of carbon dioxide also within this layer, so that means photosynthesis by plankton, which are aquatic producers. Now, due to phytoplankton and zooplankton that is abundant in the continental shelf, that means there will be abundance of food and therefore more fish will be found there. So obviously these are just the reasons why you have more fish around the continental shelf. And another thing is upwelling takes place. Now, these upwelling are areas where minerals at the ocean floor are brought up to the surface by current. So usually cold current from the ocean floor move upwards, and as it's moving up, it brings along with it nutrients from the ocean floor down to this area within the continental shelf up where most of these phytoplanktons, we also use these minerals for their own life supporting system. So fish, we feed on them, and as a result, because of high amount of minerals and nutrient there, then there will be high abundance of fish. Now, the next we'll look at how cold and warm currents affect fish distribution. So cold and warm current. So features that we'll look at is, in the case of salinity, cold currents have low salinity, while warm currents have high salinity. In the case of density, cold current is highly dense, while warm currents have low density. In the case of temperature, cold currents have low temperature, and warm currents have high temperature. Flow, it flows from beneath the ocean up to the ocean surface. Why this flow on the surface of the ocean? Why nutrients? It has high nutrients due to upwelling from beneath the ocean, which is good for fish food. Why warm current is poor in nutrients. So as a result of this, you find out that since cold currents have upwelling, low salinity, high density, the temperature is low, obviously fishes are cold-blooded organisms. So as a result, the fish concentration within areas that have cold current is high, while the fish concentration within areas that have warm current is low. Okay, I've talked about upwelling. So next, we'll look at how to describe how El Niño Southern Oscillation phenomena and its effect on fisheries. So we've been able to cover the aspect of continental shelf, warm and cold current. So now let's look at how El Niño Southern Oscillation affects its effect on fisheries along the Pacific coast of South America. So you see, the El Niño Southern Oscillation is a term used to describe changes. It's used to describe changes in weather pattern in the Pacific Ocean. It's used to describe changes in weather pattern in the Pacific Ocean. Now, in El Niño year, in a non-El Niño year, this is what happens. Now, you have remember, it happens within the coast of South America. So within the Pacific Ocean, within South this area, this is where these events take place, where we have South America and Australia. So the first thing you need to know is what happened in a non-El Nino year. Then we'll be able to tell what happened within an El Nino year. Now, first, there are two types of wind that control this whole process. We have the equatorial wind, which is a warm current that is supposed to move from the equator up to the poles. Then we now have a cold current called the Peru current that moves from the ocean floor down to the surface. So what it does is it brings along with it nutrients. So there's high amount of upwelling here because it comes along with nutrients. And because it comes along with nutrients, you expect that there will be high amount of fish population within the coast of South America. So quickly, let's just read through it. Strong warm equatorial trade wind current flow westward from South America towards Australia. So the equatorial current flows flow westward, because if you draw your cardinal point here, this is west, this is east, you have your north and south, So the equatorial wind flow westward from South America, and the equatorial wind is a warm ocean current. That's why I see it here. It's a warm equatorial wind. Now, when the trade wind reaches the coast of Australia, when this warm equatorial trade wind reaches the coast of Australia, it has become hot. It has wet mass which rises up and condenses to form conventional rain. That means within this area, as it comes to this area, it rises, condenses, and form conventional rain. That means there will be high amount of precipitation here in form of rainfall within this region in a normal year, so which can actually lead to flooding. So the high conventional rainfall can lead to flooding within Australia and this area. So also in a normal year, an upwelling of cooler nutrient-rich current at the coast of South America means there will be high concentration of fish. So this upwelling taking place using by the Peru current. So it leads to low amount of rainfall in South America. So there will be low amount of rainfall here, which can lead to possibility of drought, because what you have here is majorly warm current, and the equatorial wind has gone westward and lead to high rainfall here. Now, this is what happens in a non-El Nino year. Then in an El Nino year. Now, in an El Nino year, what happens? You see, it's just more like the opposite is the case. So if I draw my cardinal point here, north and south, west and east. So what did you observe? Now in a El Nino year, the warm equatorial trade wind will now move eastward. It moves eastward in an El Nino year, and it moves eastward. That means Australia will now experience low rainfall, therefore it can experience conditions of drought. Then because it has moved westward, then there will be warm. South American Ocean will become warmer in El Nino year. Therefore, there will be high amount of rainfall now in South America, especially Peru, which will now lead to flooding within this area. However, because the warm equatorial trade wind has changed direction westward, it will now lead to low amount of fish distribution in South America, because the cold current will no longer be that effective. Simple, because there will be no more upwelling. That's just it. That is what happens in El Nino year. So in El Nino year, the opposite is the case. Weakening the warm equatorial trade wind current flow eastward from the coast of Australia, Indonesia towards South America. So this, I think Indonesia is somewhere here. So it flows westward now. Now, this will lead to high rainfall in South America with drought condition in Australia. So lack/no upwelling of current of cooler nutrient-rich water, which will lead to lack of nutrients in South America, therefore decrease the fish and marine creatures. Now, impact. We are done with fish distribution. Now, let's look at impact of exploitation of the ocean. What is the impact of exploitation of the ocean? So, impact of exploitation of the ocean or fisheries. Simple. Now, one of the major impacts is overfishing. We also have overfishing occur when more fish are caught than the population can replace through natural reproduction. Now, the impact is it can lead to extinction of some fish species. It leads to reduction in biodiversity of fish, pollution of marine water bodies where oil and liquid will spill. So chemical and solid element discharge into water bodies by fishing boats. Now, so these fishing boats can lead to pollution. Vessels and trawlers are often hurt marine life. Now, we also have effect on bycatch, on target and bycatch species. Now, bycatch also has an effect on overfishing. It occurs when fishermen come through with large nets to catch bigger fish. So many times larger fish and mammals are caught in the net, such as dolphins and sharks and sea lions. Now, rather than releasing these beautiful creatures back into their habitat, many are sold or disposed of, thereby affecting the biodiversity within the ocean. Now, how farming of marine species reduces the exploitation of fisheries. So how farming of marine species reduces the exploitation of fishes. Now, if you look at your syllabus, sorry, let me just go back a little. If you look at your syllabus, the impact of exploitation of the ocean is just these two: overfishing and target and bycatch species. Then you can elaborate to this extent, lead to extinction, reduction in biodiversity, pollution of marine water by fishing boats and the rest. So what is the how farming of marine species reduces the exploitation of fisheries? Now we have mariculture, which is a specialized branch of aquaculture involving the cultivation of marine organisms for food and other products, marine organisms for food and other products in the open ocean and enclosed section of the ocean or in tanks within the ocean to just cultivate some marine organisms. Then we have aquaculture, which is less commonly spelled aquiculture. It's also known as aqua farming. Is the farming of fish, crustaceans, mollusks, aquatic plants, algae, and other organisms within the ocean. So this helps to reduce the exploitation of the fisheries within the ocean and other marine species, if you can go into mariculture and aquaculture processes. Now, management of harvesting of marine species. So now let's look at the strategies for management of harvesting marine species. Now, if you're going to fish, so these are the processes and no the methods that can be used to manage for the management of harvesting of marine species. One, we have net size and mesh size. Now, by increasing the size of the holes in the net, just like this, if you increase the size of the holes in the net, only matured full-size fish can be caught, and immature fish can escape and eventually breed, allowing the population to recover. That's one method, your net size. Now, two, other species and specific method, you can use a method called pole and line for fishing. Now, pole and line, which is a fishing, usually mean a particular type of rod. Look at it, a rod and line fishing, which fish are attracted to the surface with a bait fish. Now, in this process, it's a process called churning, and it helps to reduce bycatch. And also, you cannot catch more than one fish at a time. Next, we have quota system in management of marine fishery. Quota system, where we have legislators. Example are government set limits on how many and what type of fish can be caught using quota system. Now, the limits are set according to the information gathered from network across the world about fish population. Next, we have closed seasons, where government and other legislative bodies can pass laws that can close fisheries down for part of the year and majorly during a breeding season. We also have protected areas and reserves. Protected areas and reserves. Some fisheries are protected by preventing fishing in certain areas. often where the target species is known to breed. So protected areas and reserve, closed seasons, quotas, we have net size, we have pole and line fishing method. All these are method of fish management. Then fisheries. The last we'll look at is international agreement. It's also a method for managing. Remember, we are looking at management of harvesting of marine species. So the strategies. The sixth is international agreement. Now, international agreement is needed to regulate fisheries in international waters, leading to the United Nations Convention on the Law of the Sea. United Nations Convention